So in the assignment, the last question we had discussed was which one? Fifth one or sixth one?
Sixth one. Yes.
So seventh one. Right. Here it says if the minimum and maximum values of this function on the interval a to b are 2a and 2b, it's similar to what we have done, right?
Yeah. Yeah.
The function is minus half x square plus 13 by 2, and minimum and maximum values are 2a and 2b on the interval a to b. Okay, so we have to find a and b. The first thing you should do is draw the graph of this thing. So if you look at it, it's a negative half here, right? So the
Yeah. So
graph
it's
will
gonna
be,
be downward.
yeah, graph will be pointed downward. So if it was simply like this, minus half x squared, this is like minus half x squared graph. But you have to add a plus 13 by 2 to it, right?
Yeah.
So if you add something to the graph, y is
It'll
equal
go
to f
up
of
more.
x. So it will go up by 13 by 2, right?
Yeah.
So the real graph will look like this. Y is
Right.
equal to minus half x squared plus 13 by 2. When x is 0, y will be 13 by 2.
Right. That's the vortex.
Right, that is the vertex. And now we have to figure out on A to B region what is the minima and what minima should be 2A and maxima should be 2B, right?
Right.
So again, we will take three cases. The vertex is our point about which we will think of where A and B are, right?
Yeah.
So basically, we can say both A and B are somewhere here, or both A and B are somewhere here. And the third case is A is behind and B is ahead, right? These are the three possibilities. A and B can both be greater than 0, or can both be less than 0, or can 0 could be in the middle of it, right?
Yeah.
Why am I doing these three possibilities? Because we have to analyze the quadratic function only in those regions, right? The question is saying minima and maxima on what interval? X should belong to A and B. Correct?
Yeah.
So if you look at the interval in this case where both A is greater than B is greater, not A is greater than, B is greater than A is greater than 0. This is case 1. In that region, the graph will look like this graph, right? This portion. Correct?
Yeah.
So the minimum value of this graph will happen here and the maximum value will happen here, right? Correct?
Right.
So minimum will be what? Minimum will be f of b and maximum will be f of a. Correct?
Yeah.
And according to the question, the minimum is 2a and the maximum is 2b, right?
Yeah.
So now we will try to solve these two equations and try to find a and b and hope that this satisfies the condition that we have taken in this case. Correct?
Right. Yeah.
Because in our case, we have said both are positive and a is less than b. So if you put f of b here, you will get minus b square by 2 plus 13 by 2 is equal to 2a. And here you get minus a square by 2 plus 13 by 2 is equal to 2b, right?
Yeah.
If you multiply by 2 everywhere, minus b square plus 13 is equal to 4a. And we are getting 13 minus b square is equal to 4a. And now in our case, a is positive. So right hand side is positive, right?
Yeah.
So b square is coming less than 13. because left hand side should also be positive now. Correct?
Okay. Yes.
So b square is coming less than 13 from here, and we are getting a is equal to, okay, so from here what are we getting? We will get a similar relationship. A square is less than 13 from here, and then we can say that let's combine the two equations, because here the equation is what? 13 minus a square is equal to 4b.
Yeah.
We have to make it one quadratic in order to make something happen from here. So what we can do is 13 minus a square is 4b, and 13 minus b square is 4a. So let's subtract the equations,
Yeah.
because
Yeah.
that will cancel 13, right? So
Right.
what I'll do is 13 minus b square minus 13 minus a square is equal to 4a minus 4b, right?
Yeah, which gives b minus a and b
A
plus
square
a.
minus b square is coming here, right?
Yeah.
And this side is 4 times a minus b,
Yeah.
correct? Since a minus b is not equal to 0, we can divide by a minus b, and you get a plus b is equal to 4. Here,
Right.
by dividing a minus b, you will get this, right?
Yeah.
Now that we have this condition, we can use that in these equations, because now we can write a as 4 minus b, right?
Yeah.
And we'll put that in this equation, for example, and you will get 13 minus b square is equal to 4 times 4 minus b, right?
We can just substitute like we got a plus b equals to 4, right? So b equals to 4 minus a. So can we just substitute that in one of the equations?
What do you think I've done here?
Oh, sorry, I didn't follow.
You're doing the same thing, no? I'm putting a as 4 minus b.
Yeah, right.
I'm getting 13 minus b square is equal to 16 minus 4b, and I'm getting b square minus 4b plus 3 is equal to 0. And from here, b is coming out to be 1 or 3. If I put b as 1, a will be 3, but that is not allowed because a is supposed to be smaller, right?
Right.
So b should be 3, a will be 1, and I'm getting a proper solution in this case. b is 3, a is 1. Correct?
Yeah.
So the question was asking us to find out a and b. So we have found it, one solution we have found. Similarly, you can do the same type of thing for the other case 2 and case 3 also. Correct?
Right.
In case 2, the minimum value will be f of a and maximum value will be f of b. Right? And in case
Yeah.
2, we have the condition a is less than b and less than 0. All the things are less than 0. And you may or may not get a solution. It depends on the equation. You have to work it out yourself. Do you understand what I'm saying?
Right.
But the logic of the whole problem, so far what we have done, should be clear what we have done. Right?
Right.
You have to analyze it in separate cases because we don't know what is A and B, where they are, whether they are positive or negative. So we have to be general and we have to try all possibilities. Right?
Yeah.
Okay. So similarly, you have to work out the other cases and see whether you're getting it or not. We'll move on to the next question. Uh, Next question is question 8. Here, okay, they have said some stuff. Let B and C be real numbers. B and C are real, and they satisfy the equation B is less than 2 is less than C. And suppose when B is less than equal to X is less than equal to C, the function x square minus 4 mod x, okay, y is equal to x square minus 4 mod x plus 4 this function has the maximum value 4c, has the maximum value 4c, and minimum value of b. Minimum value of b. You have to find b plus c value.
Yeah.
So they have given us some information that b and c are such that 2 lies between them, and obviously b is smaller than c. And then they are saying that in the interval where x lies between b to c, right?
Yeah.
You have to find maxima minima of this, and that has to be 4c and 4 and b. Correct?
Right.
Okay. So this expression, because of the absolute value sign, you should realize that the graph will be x squared minus 4x plus 4 if x is greater than equal to 0, and x squared plus 4x plus 4 if x is less than 0. Do you understand this?
Right.
Mod of x will be like this, right? X if x is greater than equal to 0, and minus x if x is less than 0.
Yeah.
I hope you know what modulus of x is. This should be okay.
Yeah.
So the graph actually looks different for x positive and x negative. And now we have to think, where is this going to be? B to C. So, okay. So here it is possible that x could be negative because b could be smaller than 0 also, right? The x that we have to analyze is between b to c, but we don't know whether it includes negative values or not, right? If you think of the number line, we know that 2 is here and b is here and c is here, but we don't know whether it is negative or positive, right? 0 could be here, right?
Yeah.
It could be like this, or it could be another case, could be where 0 is here and b is here and 2 is here and c is here, right?
Yeah.
These are both possible cases, but the analysis will be different, because if this is the case, the question is simpler because we don't have to worry about x being negative now. Correct?
Right.
Because x lies in this range.
Yeah.
But in case 2, we have to worry about x being negative.
Negative. Yeah.
So the graph will look little different in case 2, right?
Yeah.
So first we'll analyze case 1, and then we'll see what has to be done for case 2. So case 1, we only have this situation: b 0 is less than b, less than 2, less than c, and x lies between b to c, right?
Right.
Okay. And the graph in that case is only this graph, the top, this one. Correct?
Yeah.
Now this graph is pretty simple because this is a perfect square. Y is equal to x minus 2 whole square. So this graph looks like this. It touches the x-axis at 2 and is upwards like this. Correct?
Yeah.
Straightforward graph for this. And our B and C are somewhere here and here, right?
Right.
So if our analysis has to be from B to C, it could be like this. Something like this is our portion where we have to discuss the maxima minima. And if this is the situation, the minima is always going to be this vertex, right?
Right.
It is obvious that minima is always going to be the vertex in this case, right?
Yeah.
So if the minima is always going to be the vertex, the y value is equal to 0 at the minima is 0, right? Correct?
Right.
And according to the question, they had said b is the minima, so b is 0 is coming, right?
Yeah.
And so then b becomes 0 and this is 0. So the analysis is from 0 to C. And in that portion, the maximum value will either be depends on whether C is bigger than 2 or C is lesser than 2. Think about it. Why
Yeah.
am I saying that? So this is my graph, and this is my 0. This is my vertex. And C could be here or C could be here, right? Far away, right? We know that B is 0, correct?
Yeah.
Do you understand what I'm saying? C has two possibilities. One is it's smaller than 4, and one is it's bigger than 4, right? Why is 4 important for us? Because our first point is 2 units behind the vertex, right? So if C is smaller than 4, if C is smaller than 4, then the maximum value will be this, right?
Right.
But if C is greater than 4, the maximum value will be the higher value will be f of C. Correct?
Yeah.
Do you understand what I'm saying?
Yeah.
So in the question they had said maximum was 4C, and maximum value in this case f of 0 is 4 because our function was y is equal to x square minus 4x plus 4. So 4 is equal to 4C, then C is equal to 1, which satisfies the condition that C is less than 4, right?
Yeah.
So one possible solution is B is 0, C is 1. Let's say this case f of C is equal to C square minus 4C plus 4, and that should be equal to 4C. So you're getting C square minus 8C plus 4 is 0. And from here you will get C is equal to, by solving this, 8 plus minus root over 16. No, B square is
Give me
64.
a moment, sir. I'll be
Hmm.
back. Someone's at the door.
Hmm.
Okay, I'm back.
So in the other case, C is greater than 4. In that case, f of C is the maximum, but f of C should be equal to 4C according to the question. So we'll get an equation like this, and the solutions are coming. C is equal to 4 plus minus 48, root 48 by 2. So that is going to be 4. So 2 root 3. So you cannot take the 4 minus 2 root 3 because that will make it smaller than 4. So you have to take C is equal to 4 plus 2 root 3. So the second option is B is 0 and C is equal to 4 plus 2 root 3. Right?
Right.
So B plus C values, we are getting one value of B plus C is 1. One value of B plus C is 4 plus 2 root 3. And this is all coming from case 1. Right?
Okay. Yeah.
Case 1 was the situation where B and C were both positive and 0 was behind it. But in case 2, we have to analyze the situation where B is less than 0 is less than 2 is less than C. Right?
Right.
And X belongs to B to C. And Y was X square minus 4X plus 4 if X is greater than equal to 0, and X square plus 4X plus 4 if X is less than 0. So here you will analyze the graph you split the portion into two parts. One is where x belongs to 0 to c. That has a separate graph. That has a graph of this one, right?
Yeah.
And one is when x belongs to b to 0. And in that case, the graph is x squared plus 4x plus 4, right? Correct?
Right.
So the graph has to be drawn carefully here. For x belongs to 0 to c, I have the same graph as before. So it is like this. The vertex of this graph was at x is equal to 2. But for x belongs to b to 0, the graph is this graph. This graph's vertex is at minus 2, by the way. If you see, this is x plus 2 whole square, right?
Right.
This graph is like this, where this is the minus 2 vertex, and b can be somewhere here, or b could be somewhere here. Depends. We don't know where b is. Similarly, c could be somewhere here behind 4, or c could be somewhere here ahead of 4. Correct?
Okay.
Now we have to do maxima minima of this function from b to c. So one case is b is somewhere here and c is here. In that case, you can see minima is at this point, right? And maxima is at this point. Do you understand what I'm saying?
Yes.
B is ahead of minus 2 and C is less than
Less
4.
than 4.
In
Yeah.
that case, maxima is here, maximum value is 4, minimum value is 0, right?
Right.
And from there, according to the question, minima was for B, and that doesn't work because then we get B is 0, right? But B is less than 0, right? It's a contradiction, right?
Yeah.
So this case doesn't work, doesn't give us a solution. So now we'll take the case where B is here, but C is beyond 4. But again, you see minimum value is still 0 only at 2, right?
Right.
So that also will not work because that will give us B is 0, right? But we are doing this whole case where B is less than 0, correct?
Yeah.
So that also doesn't work. So we have analyzed all cases where B is somewhere here and C is either here or here, right? Both cases don't work, correct?
Right.
The other cases are when B is below minus 2 and C could be here or here. But then we have to analyze the graph from here to here. Clearly, the minimum value again is 0, right? Again, it doesn't work because B is becoming 0, but B is supposed to be less than 0, right?
Right.
Do you understand that nothing will work here? This case doesn't give us any solutions
Right.
because the minimum value is always going to be 0, but according to the question, minimum value is supposed to be B.
Okay.
Do you realize that there is a contradiction?
Yeah.
So we have eliminated any possibility of this happening. So a solution will be the two answers that we were getting in from the first case, where we said that 0 was less than B is less than 2 is less than C. And depending on the location of C, whether C is less than 4 or greater than 4, we got two options. Correct?
Yeah.
The solutions were B is 0, C is 1, or B is 0 and C is 4, 4 plus 2 root 3. This is the answer that came when C was less than 4, and this is the answer that came when C was greater than 4.
Right.
So that is how you're supposed to analyze the graph and all. I hope you are getting the hang of what we are doing.
Yeah.
Question 9, did you try?
I did.
What have you gotten so far?
So,
The question says alpha and beta are roots of x 7x
7x
square
squared.
minus p plus 13x plus p square minus p minus 2 is equal to 0. Okay. And they have also given us 0 is less than alpha is less than 1 is less than beta is less than 2. Okay. They have given us the location of alpha beta in the region 0 to 2. Right?
Yeah.
Find the range of values of p. Find the range of values of p.
I tried like putting 0, 1 and 2 in like x, and tried finding like if it's like more than 0, less than 0, something like that. Like when I was trying.
Okay. So this quadratic is an upward facing quadratic, right?
Right.
Lower root is alpha, bigger root is beta. So this is marked alpha, this is marked beta. And obviously they have told us that 0 is here somewhere, 1 is somewhere in the middle, and 2 is somewhere here.
Yeah.
Correct? Okay. So first of all, if there are two real roots, alpha and beta, what is the first condition we can say for this quadratic? There are two real roots, right?
Yeah. So the discriminant is supposed to be
Greater than 0,
greater
right?
than 0. Yeah.
That is the first thing you should say because there are two distinct roots, right?
Yeah.
Then you can say that according to the graph, f of 0 will be positive or negative.
It will be positive.
So f of 0 is greater than 0. That's first thing. Third thing
Yeah.
is f of 1 will be positive or negative.
Negative.
And finally, f of 2 will be positive, right?
Positive. Yeah.
These four conditions only you have to solve. From here, we should get all the possible range of p.
Right.
That's all. There is nothing else to do here. Because there are four conditions. All the conditions will get some conditions on p, right?
Yeah.
So let's now solve one by one each condition. So we'll say all four have to be satisfied. So let's do d greater than 0. That becomes p plus 13 whole square minus 4 times 7 times p square minus p minus 2 is greater than 0. Right?
Yeah.
So this becomes p square plus 26p plus 169 minus 28p square plus 28p and plus 56. Correct?
Right.
So we are getting minus 27p square, 26p and 28p adds up to 54p and plus 172.25, right? Something like this is coming, right?
Okay. Yes.
We can multiply by minus 1 to make the first term positive, but then we'll have to reverse the inequality, right?
Yeah.
We are multiplying by minus 1 throughout and saying it's less than 0. And then obviously you can see that it will be divisible by 9 everywhere, right? So I'll divide by 9. Okay. This is coming as 25. Correct?
Yeah.
Now, this is easily factorizable, hopefully. 1 second. Minus 75. Can we get 75, 15, 6? No, it is not easily factorizable. Okay, doesn't matter. We have a quadratic inequality, right?
Yeah.
This quadratic expression has to be less than 0, right?
Yeah.
Always, when you have a quadratic inequality, you should always draw a rough graph and then you'll get the idea. So look at this quadratic. It has first term positive, right?
Yeah.
So obviously it's an upward facing
Upward
quadratic,
facing. Yeah.
right? So it has to be less than 0, right? So upward facing quadratic, it couldn't be like this or like this then, right?
Yeah, I mean, it's like the
Like this, right?
y-intercept is minus 120, sorry, minus 25. So,
No, what I'm saying is it cannot be the two cases where there are no roots or equal roots.
yeah,
Because in those cases, you will never have it negative, right?
right.
It has to be the case where this is the situation, no? The graph.
Yeah,
And P should be between the roots, no? Then only it will be negative, right?
yeah.
The only way for this quadratic to give total answer negative is when the variable is between the two roots, right?
Mm-hmm.
Are you understanding what I'm saying right now?
Yeah,
It couldn't have been these possibilities. Right? So, if you look at the quadratic and find the roots, we can say that P should lie between the two roots, right?
right,
So, let's find the roots of this quadratic. It will be 6 minus B plus minus root over 36 minus minus plus 300. So, 336, right? By 2 into 3, right? Correct.
right,
So notice that 300, let me just check the calculations once. B square is, say, 36 minus minus plus 12 into 20. Okay, maybe I made a mistake. 4 into 3 into 25. So 12 into 25 is 300. So 36 plus. Okay, it's correct only. So 6 into this is 56. 6 into 56. So it doesn't give us much, but we can take a 4 common for sure. 14 fours are 56. 4 into 6 into 14. So 4 common comes out of the root, becomes a 2. And inside you have root 84. So it becomes 3 plus minus root 84 by 3, right? Correct?
right.
And I'm going to say that the P should lie between the roots. So what that means is P lies between 3 minus root 84 by 3 up to 3 plus root 84 by 3, right?
Yeah,
This is the first thing that I have gotten. This came from here. I hope you understand what I have done.
yeah,
When you write discriminant greater than 0, we get an equation like this, and this is a quadratic inequality. You should always be able to solve quadratic type of inequalities because now you know the graphs of the quadratic, right? We say that the quadratic will be negative if the p value is between the roots. I hope it is clear completely this part. Is it okay?
yeah, it is.
Okay, so now we'll look at the other conditions. We will keep our answer here. The answer here is that P lies between the two roots, and we have found it here. And we'll do the other conditions also. So f of 0 is greater than 0. So in this, put f of 0. So you're getting 0 here, 0 here. So you should have P square minus P minus 2 is greater than 0, right? Correct? This
Right,
can be easily factorized. P square minus 2p plus p minus 2 is greater than 0. So p common p minus 2 plus 1 common p minus 2 greater than 0. We're getting p plus 1 into p minus 2 is greater than 0, right? So if you notice, this is a product of factors. It has to be positive, and the values at which the factors are 0 are minus 1 and 2, right?
right.
So when the answer is when p is bigger than 2, both factors are positive, right?
Yeah,
This is called the wavy curve method. I hope you have seen it before. When both the factors are positive, the inequality will be satisfied. So that will happen when p is greater than 2. But in the middle, you will realize that one of them is positive, but the other one is negative.
Yeah.
So p cannot lie between -1 and 2, right?
Right.
And other cases, p is less than -1, right?
Yeah.
Because in that case, both are negative, which makes the overall thing positive.
Right.
So that's how you solve inequalities, quadratic inequalities, where we know the factors. Here we were able to factorize it, so we can easily check the sign of the factors, right?
Yeah.
So we are getting the answers from here at p greater than 2 and
P less
or
than -2.
p
-1.
less than -1, right?
Right.
Now we have to combine that with our original answer from here, okay? So notice that we can do that later. We'll don't have to do it at right now because we still have two other conditions, right?
Right. For
Hmm.
f of 1, we get -2 is less than p is less than 4. Like, I did
Huh.
the equations you were doing. I got the same for p
Huh.
f of 0 and f of 1 is this.
Okay, 1 second. If you do f of 1, you get 7 minus p plus
P plus
13
13 plus
plus
p
p
square
square minus p minus 2
is 2.
is less than 0.
Yeah,
So you're getting p squared minus p minus p. So minus 2p and
-8.
minus 6 and minus 8 is less than 0.
So p
And
-4 and p plus 2.
uh, p plus 2 is less than 0. And now again, see, wavy curve we will do. And it will be between -2 and 4. In between, it will be negative, right?
Yeah,
Ahead, it will be positive, and below, it will be positive, right? So from here, we are getting p is between -2 to 4, right?
yeah,
So three answers we have gotten. Ultimately, we will have to do intersection of all because all have to be satisfied, right?
yeah.
So now finally, we'll do f of 2 is greater than 0. So
Which is 28 minus 2 bracket p plus 13 plus p
mhm.
square minus p minus 2.
So 28 minus 2p minus 26 plus p square minus p minus 2 is greater than 0. So we are
0
getting p square minus
minus
3p
3p.
and plus 2 and minus 2 gets cancelled
Yeah.
is greater than 0, right? So
So
this
p
is
outside and p minus 3. So p is less than 0 and p is greater than 3.
p less than 0 and p greater than 3.
Yeah.
Okay, so now we have four answers, and what we have to do is put all of them on the number line. That's how you do intersection, okay?
Okay.
So what we'll do is we'll mark a big number line we'll make and we'll put all the relevant points on it. Okay. So let's see. So like this, you have a number line. Let's calculate roughly what are the values of these. Okay. We don't have to be very precise. We just have to know which if are the reasonable region where it is. Okay. So this is 1 minus root 84 by 3, right? Root 84 is roughly 9.1 maybe, right?
Okay.
By 3. So this is roughly 1 minus 3, roughly. So close to -2, right?
Yeah.
But 3.05, let's say, slightly above 3. So minus 2.05, right?
Right.
I am doing a very tentative calculation. I just need the region where it is. I don't have to be precise about it. Okay.
Okay.
Similarly, here 1 plus, this time you have to add this 3.05. So it will be around 4.05, right?
Right.
Correct. So 1 point is we'll put it as 3 minus root 84 by 3, and that is actually close to minus 2.05, right? And 1 point is here, which is 3 plus root 84 by 3, which is close to 4.05, right?
Yeah.
Correct. our answer, according to the first condition, it should be between these two, right?
Yeah.
Then we have to use the second condition. We should put a 2 and put a -1, right?
Yeah.
Then we should also put a 0 and we should put a 3 also, right?
Yeah.
And then we should put a 4 and -2, right? Do you understand?
Yeah.
So, okay, I have to make it a little bigger because otherwise you'll get confused. So I'll just make the number line a little bigger. So this is minus 3 minus root 84 by 3. This is close to this -2, right? But it is smaller than -2, right? Then we have a -1, then we have a 0, then we have a 2, then we have a 3, then we have a 4, and then we have 3 plus root 84 by 3. Do you understand?
Yeah.
Now we will do intersection. So first condition was P should lie between this and this, right? Correct?
Yeah.
Then the second condition was P should be smaller than 0 and should be greater than 3, right?
Yeah.
Then this condition is P should be between -2 to 4. So -2 to 4,
Four.
right?
Hmm.
So notice that now combining all three, we are getting -2 to here and then from here to 4, right?
Yeah.
Do you understand?
Yeah.
Because you have combined all three cases now, right? Correct.
Right.
And then one thing is left, I think, one condition greater than 2 or less than -1, right? This one, correct?
Yeah.
So greater than 2 is this portion and less than -1 is this portion, right?
Yeah.
But so far with the other conditions, I have gotten it as -2 to 0, right?
Yeah.
So less than -1 means this cannot be allowed, right?
Yeah. So -1 to -2.
-2 to -1, this is one region. And then above 2 anything, and but we have already identified 3 to 4, right?
Yeah. So it's 3 to 4.
So 3 to 4, and that is our answer.
Got it.
So basically, you don't have to get worried about it. You have to do one by one all the conditions, right? And
Yeah.
because of so much data was given that alpha is greater than 0, alpha is less than 1, beta is between 1 and 2, we can say f of 0, f of 1, f of 2, all their signs, right?
Yeah.
And we can also say discriminant is positive, correct?
Right.
So 4 conditions are there. You solve each one by one, and then you do intersection nicely. Do you understand? I hope it is clear what we did.
Yeah. It's clear.
Okay. Then we come to question number 10. Question number 10, it says fx is a quadratic function such that first of all f of -1 is 0, and secondly the inequality x is less than equal to f of x is less than equal to 1 plus x squared divided by 2 is true for all real x, right? And we have to find f of x basically. Do you understand the question?
Yes.
Did you try it little bit here?
Yeah. Give me a sec.
So tell me what all you have tried.
One sec. So I just tried randomly, like I put -1 in like x,
Mhm.
and that equals to 0, right? So
Mhm.
what after simplifying, I got as r equals to q minus p.
What do you mean R?
R is in the thing, right? No, wait, I'm looking at a different question.
Yeah.
No, wait, I don't know how to do this.
But did you try a little bit? No, you didn't try much.
Not really.
So we have to find f of x. We know that it's a quadratic. You should take f of x as a general quadratic ax squared plus bx plus c, right?
Yeah,
Our job is to find a, b, and c, correct?
right.
The information that you have is that f of -1 is 0. So if you put -1 into it, one information you have is a minus b plus c is 0, right?
Yeah,
And the other information is that for any x value, the inequality is true that x is less than equal to ax squared plus bx plus c is less than equal to 1 plus x squared by 2, right?
right.
You have to use this inequality to get some more information about the quadratic. You already have one equation, right?
Yeah,
If you had two other relations, two other conditions on A and B and C, then the question can be solved, no? Because then you can find ABC.
yeah.
So why don't you use this information? This is true
Hello.
for, hello?
Yeah, yeah.
This is true for all real x. Why don't you use this to get a few more conditions? This inequality is true for all real x. So why don't you put some possible values of x and see what is coming? For example, can we put x is equal to 1? And it should be true, right?
Right.
So if I put x is equal to 1, I will get 1 is less than equal to a plus b plus c is less than equal to 1 plus 1 by 2, right?
Yeah,
What is this equal to? This is same as 1, right?
yeah.
So that guarantees that a plus b plus c is equal to 1, no?
Okay, yeah.
Because you're getting 1 is less than equal to this, less than equal to 1. Correct?
Right.
So you get a second condition that a plus b plus c is equal to 0, is equal to 1. Correct?
Yeah.
If I add it to the first condition now, if I add it, I'll be able to cancel the b and I will get 2a plus 2c is equal to 1. So a plus c is coming as half, right?
Yeah.
Do you understand?
Yeah.
And notice that if a plus c value we know, then we can say b value also because b is equal to a plus c from here. Correct?
Right.
We have gotten a plus c is half, so b is equal to half we have gotten, right?
Yeah.
So in our quadratic, now we know that b is half and the quadratic is now ax squared plus x by 2 plus c, right? And we also know that a plus c is half, right? Correct?
Yeah.
So c, instead of c, can I write it as 1 minus half minus a?
Okay, yeah.
So the quadratic is becoming like this. ax square plus x by 2 plus half minus a, right? Correct.
Right.
And this quadratic should satisfy these conditions. So we can use one of the inequalities. We can say fx is always greater than equal to x, right?
Right.
Correct. So we can
Yeah.
say ax square plus x by 2 plus half minus a is always greater than equal to x, right?
Okay.
This is true for all real x. So we can bring it to one side and we'll get ax square minus x by 2 plus half minus a is always greater than equal to x, 0, right? Correct.
Yeah.
So this quadratic is always positive, can happen only when discriminant is less than equal to 0, right?
Right.
Because this equation, if discriminant is positive, then it will have like this graph, which will be negative sometimes, positive sometimes, right?
Yeah.
Any quadratic which has real roots cannot always have the same sign. It will have positive or negative signs, right?
Yeah.
But the quadratic has to have always positive sign, which means it should either be a graph like this or a graph like this, right?
Okay. Yeah.
So the discriminant is either less than 0 or equal to 0, right?
Mm-hmm. Yeah.
So on this, we can say discriminant is less than equal to 0, and that will give us a condition on A now, because discriminant will come in terms of A, correct?
Right.
So let's calculate that. 1 by 4 minus 4 times A times half minus A should be less than equal to 0, right? So 1 by 4 minus 2A plus 4A square is less than equal to 0, right?
Right.
So you can multiply by 4. So 1 minus 8A plus 16A square is less than equal to 0, correct?
Yeah.
16A square minus 8A plus 1 is less than equal to 0. This is my inequality, but you can see that this is a perfect square. It is 4A minus 1 whole square.
Right.
It can never be negative, it can only be 0. Perfect squares cannot be negative, right?
Yeah.
So this inequality is satisfied only when this is equal to 0, which means A should be 1 by 4, right?
Yeah.
And if A is 1 by 4, then C is 1 by 4. And we already
Okay.
got the value of B as half, correct?
Yeah.
So the quadratic becomes for us 1 by 4x square plus 1 by 2x plus 1 by 4. So notice what we have done. What are the things that we did to solve this problem? We had f of x as a general quadratic like this. We were given f of minus 1 is 0. So we had a relation a minus b plus c is 0. We were also given f of x is always satisfying this condition, right?
Yeah.
So we said that, okay, it will always satisfy for any value of x. Let's pick some nice value of x. A nice value of x is 1 because both left hand side and right hand side become equal.
Yeah.
We are getting 1 is less than equal to f of 1 is less than equal to 1, which means f of 1 is 1, which means a plus b plus c is 1. We already have a minus b plus c is 0. So this totally adding it means a plus c is half. And from this equation, a plus c is equal to b, so b is half. Correct?
Right.
Then we got the quadratic like this, ax squared plus half x plus, instead of c, I can write half minus a. And this quadratic is supposed to be always greater than x, right?
Yeah.
Bringing it to one side, we get an inequality. Ax squared minus 1 by 2x plus half minus a is always greater than equal to 0. And that can only happen if discriminant is less than equal to 0.
Right.
I hope you are understanding the logical step here from here to here.
Yeah.
That's what you have also got to use, right? Once you do this, you will get 4a minus 1 whole square less than equal to 0, which automatically means that a can never be anything other than 1 by 4. Because in any other case, it will be positive. Correct?
Right.
Okay. So now what I want you to do is, if you haven't tried it yet, you should try this one, the 11th one.
Uh,
Did you try it before?
Not really. I mean, I
Uh,
didn't really understand them.
what do you mean you didn't really understand?
No, I mean it sounds pretty similar to question 10 right now. So now that I know, I'll
Hmm.
give it a shot.
Question 11 says f of x is ax squared plus bx plus c. A is greater than 0.
So it's supposed to be a
Huh.
U-shaped, right?
Huh. Let x1 and x2 be roots of which equation? The equation f of x equals x. F of x
Right.
equals x. And they have also given us 0 is less than x1 is less than x2 is less than 1 by a, right?
Yeah.
First part is show that x is less than f of x is less than x1 when x belongs to 0 to x1. Basically, when x lies in this region, 0 to x1, always f of x is bigger than x and f of x is smaller than x1, right? And second part of it is prove that if the graph of f of x is symmetric with respect to the line, with respect to the line, x is equal to x naught, show that x naught is less than x1 by 2. So right now focus on part 1 of it. Don't worry about the second part right now. Try to prove part 1. We have done enough techniques that you should be able to do it. Okay.
Yeah.
You have 10 minutes. Try it out.
Yeah.
I'll be back in 5 minutes.
Got it.
So one hint I can give you, they have said x1 and x2 are roots of this, right? Correct?
Yeah. Yeah.
So we can, this is an equation. You can call a new function gx as f of x minus x, right? We are
Okay.
defining a new function g of x, and we know that this function will become 0. Gx is equal to 0 at x1 and x2. Correct?
Right.
Because x1 and x2 are roots of this equation. So f of x1 minus x1 is 0 and f of x2 minus x2 is 0, right?
Right.
So this gx is also a quadratic, no? If I bring x to this side, it still is a quadratic only, right?
Yeah.
Gx is a quadratic with roots x1 and x2, right?
Yeah.
Okay, x1 and x2 roots. Okay, now if you think of a quadratic with roots x1 and x2, let's say this is my graph of gx. This is x1, this is x2, right? This is gx graph.
Okay.
So if the two roots are known to you, you should know that the vertex will be midpoint of the roots, right? Vertex. Any quadratic, the vertex is at the midpoint between the two roots, correct?
Yeah.
So this gx, the vertex will be at x is equal to x1 plus x2 by 2, right?
Yeah.
Vertex line, correct?
Right.
Now you should realize that from x1 to the vertex, the graph of gx will decrease, and from vertex to x2, it will increase, right?
Right.
So what I'm saying is, this is my gx graph. Gx is what? It is f of x minus x. The roots are x1 and x2. And the vertex of this graph is at the point midpoint of the roots. So x1 plus x2 by 2, right? What I'm
Right.
saying is in this portion, the gx curve decreases in the portion from x1 to x1 plus x2 by 2. And then it increases, gx increases in the region x1 plus x2 by 2 to x2. Correct?
Yeah.
Now, the first part of the question is asking us to show that uh, when x is less than f of x is less than x1, we have to prove that when x belongs to 0 to x1, right? Correct? We have to show that x is less than f of x is less than
Right.
x1.
Yeah.
Okay, so x should lie in this region 0 to x1. Correct? 0 is somewhere here.
Yeah.
In this region, we can easily see that the gx curve is decreasing. Correct?
Yeah.
Gx curve is decreasing in that region, and we will use that to prove it. So, uh, if gx is decreasing in that region, for any x, let's say this is a point x in this region, 0 to x1, then this gx will be smaller than g of 0, right? I'm saying gx is less than g of 0 because the g function is decreasing,
Okay.
right? And I can also say gx will be greater than g of x1, right? Because g of x1 is 0, right?
Yeah.
I only have to look at x between 0 to x1. So g of x will be somewhere here, right? It will be bigger than g of x1 and it will be smaller than g of 0, right?
Right.
And what is g of x1? That is equal to 0, right?
Yeah.
So we are getting gx is greater than 0, right? In that region.
Yeah.
And g of x is what? F of x minus x is greater than 0, right?
Right.
So we have proved that f of x is greater than x in that region, right?
Yeah.
Similarly, you can also say that if I call another function h of x as f of x minus x1, a new function h of x as f of x minus x1, what you can say is h of x1 is 0 because f of x1 minus x1 is 0, right?
Yeah.
So h of x1 is same as g of x1 and both
Okay.
are equal to 0, right?
Yeah.
So we can say also that h of 0, which is equal to f of 0 minus x1, h of 0 is f of 0 minus x1 and f of 0 is c minus x1. This h of 0 thing, why am I writing it as c? Because f of x is ax squared plus bx plus c, right?
Right.
And then we can say that this c can also be written as, if you remember, x1 and x2 are roots of g of x, right?
Yeah.
Now, g of x function looks like this: ax squared plus b minus 1x plus c, right?
Okay.
Because it is ax squared plus bx plus c minus x, right?
Yeah.
So if x1 and x2 are roots of this, product of the roots is what? C by a, right? Product of the roots x1, x2 of this quadratic will be c by a, right?
Yeah.
So c is equal to a times x1, x2.
Yeah.
We can take x1 common here and we are getting ax2 minus 1, right?
Okay. Yes.
And we know that x1 is positive and ax2 minus 1. The question has already told us that x2 is less than 1 by a, right? Look at the question, it was given in the question. x2 is less than 1 by a is given in the question.
Okay. Okay. Yeah.
So ax2 minus 1 is less than 0, correct?
Right.
So this is negative, this is negative, this is positive. So overall it is negative, right? So what we are
Yeah.
getting is h of 0 is less than 0, right?
Right.
So therefore h of 0 is negative, and so h of x, and this is possible in any point in that region 0 to x1, right? So h of x is less than 0 for 0 to x1, any point in this region. And from here we are getting f of x minus x1 is less than 0, or f of x is less than x1. Because we got a new function, h of x is f of x minus x1, and we showed that h of 0 is negative. We have proved basically that f of 0 minus x1 is negative. So f of 0 is less than x1.
Okay, yeah.
The first part of it, did you understand what we have done?
Yeah.
This is slightly tricky, doesn't don't worry about it so much, but what you need to understand is based on the graph, we can say that in one portion before the vertex, the graph decreases. After the vertex, it increases. That's what we are doing here. Okay. And we are
Okay, yeah.
saying any x lying between this region, the graph is decreasing, and therefore the value of g of x is bigger than g of x1. And similarly, we are taking another function h of x and all, there also we are doing the same thing. What you need to do is try out the couple of problems that are left here, question 12, 13, 14, 15. But even if you don't get those, you need to start doing the book problems.
Yeah.
Question 235 onwards.
Yeah, page 35. Yeah.
Question number 235, I think. Or I don't know which
Mhm.
what I mentioned.
Yeah,
But
I know. I know.
so there will be multiple correct questions on quadratics, which you will get more practice from there. Those will be easier than the ones that we are doing right now. So try those out. You will get a lot of practice there, which will make sense. Okay. So
Okay.
next class, I want to discuss that, the tomato book. So try that out. Okay.
The what
Okay.
book?
It's called, it has a nickname. It's called the tomato book. Test of mathematics at the 10+2 level.
Oh, okay, okay.
So that book you have to try question 235 onwards. Next week, you just work on that, and whatever progress we make, we will conclude our discussion of quadratics in the next couple of classes. Then we'll move on to a new chapter. We don't have to achieve expert level in the first go. Okay. So right now we are just doing it for the first time. You are doing it for the first time, right? So
Yeah.
it doesn't have to be like you have to be able to solve every question right now. That is not normal and that is not expected also. But it should not be that you don't know some theory. Do you understand what I'm saying?
Yeah.
Problem solving will happen with practice and with experience. You'll get better. But no theory should be misunderstood, or there should not be any doubts in how to analyze graphs, what are the conditions you should get, how to analyze the discriminant of quadratics, and so on. What you need to get from all of these problem solving classes is the techniques that we are using. Doesn't mean that you should be automatically able to solve all the problems. That's not expected. So if you're struggling on the questions, it's fine, but it's not fine if you're not trying. Do you understand?
Got it.
And whatever we are discussing in class, do make notes for that, because if you make notes, then only you can recall it and revise it later. And the note
Yeah.
should not be just like what I did. The explanation should be there, otherwise you'll forget it.
Right.
Okay. So work on the next week, completely work on the book and do as many problems there as possible. Whatever issues are there, we'll discuss in class. Okay.
Okay.
Okay, fine. That's all for now then.
Thank you, sir. Bye.
Bye.